I work with Continuum Analytics, and I'll be talking about creating apps in Python that run in the browser using a tool called Flexx. So for everyone who has a laptop on them, there is a demo near the end where everyone can participate, so keep it ready. So I think it's evident that the web is playing an increasingly important role in how we publish our results and our scientific ideas. And not only allows the web to reach a very large audience, but it also allows us to create a very rich and interactive user experience. And we as scientists can use that to more effectively publish our results. So instead of publishing a static plot, we can let our users interact with the data, to explore the data, and that will allow our audience to better understand the data. And similarly, we can use this to create like small applications that allow the user to interact with certain technical concepts or scientific ideas. And this is technology that is there. We can use this as scientists. And of course, there are several projects in our stack that are already doing this, but there's much more that we can do, I think. There is, however, one problem, and that is that the language of the web is JavaScript, and JavaScript kind of sucks. So, JavaScript is known to have many flaws, and I think the contrast between Python and JavaScript is particularly large because Python is well designed, it's mostly consistent, and it's just a joy to work with, whereas working in JavaScript is often quite painful. So I might be exaggerating a bit here, but the point remains that most scientists just want to get things done, and they're happy that they know one language which they can use to do their analysis, and they're reluctant to learn another language to do their publishing, especially if that language is JavaScript. And this is the main reason, I think, why there are quite a few projects that try to bring Python to the browser in one way or another. And Flexx is one of them. So what is Flexx? So Flexx is essentially a GUI toolkit that uses HTML5 to do the rendering. And it allows you to write apps completely in Python, so also the client-side behavior. And it will transpile the Python code to JavaScript on the fly. And because it targets web technology, and web technology is essentially everywhere, it's very much cross-platform. You can use Flexx to create desktop applications for all the major platforms. It works in the notebook. You can use it to create web applications. If you have an app that does not rely on the server, you can export it to standalone HTML. And we have plans to make it work for mobile as well. So how does Flexx work? There are like three main components that form the basis of Flexx. And these are the transpiler, so that's the part that takes Python code and is able to convert that to JavaScript. There is a property and event system. And there is a component that takes care of the event loop and the communication with the browser, so the communication between Python and JavaScript. And mixing up these three concepts allows us to create a model or a certain concept that's very central to Flexx. And that is the concept of an object that exists both in Python and in JavaScript. So it's semantically a single object, but it has a representation in both Python and JavaScript. And you can define the behavior, like the Python side behavior and the JavaScript behavior in a single class written in Python. You can also create properties or define properties on that class which exist on both ends, and these are automatically synchronized, and also events are transparently communicated between Python and JavaScript. And basically this is a very powerful concept, and what's done, we have created a bunch of widgets on top of this. So let's do a demo. So I'm now using the notebook to for this demo. And if you want to use a notebook with Flexx, what you want to do is call init notebook at the very start. In general, you will import three modules, which are yeah, which are the, well, more or less the three modules that I just discussed. So app you only need like only once, like either at the start in a Python notebook or at the end of your script to enter the main loop. Event is used to define properties or connect handlers, and all the widgets live in UI. So when we run this, the Flexx is preparing the notebook. And is this large enough, by the way? Is this? No. Let me. That better? Cool. Can I make this? Yeah. So when the output of a cell is a widget, a Flexx widget, then that widget will appear below. So it's quite straightforward. Well, many widgets have properties, so you can very easily interact with them and change how they behave or what their appearance is. And further, you can very easily connect events to them. So here we have a function that is going to update the text with the given time, like in seconds, so it's not very useful, but for the sake of example. And we're using this notation, we're using decorators. Well, you don't need to use decorators, but it's sort of the preferred method. So we're binding to the mouse click event. So when the mouse is clicked on the button, we're setting the text. OK, so create a custom widget in Flexx more or less looks like this. So you, in most cases, you would inherit from the basic widget. And essentially anywhere here, you would define all the logic that is going to be executed at the Python side. And then there is this notation where you create like a subclass, but like an indented subclass. And here you can define methods that are going to be executed in JavaScript. So anything that's in here is going to be transpiled and will operate at the client side. And then we have, there's also a similar thing for both. And this is mostly intended to create properties that exist on both sides. So you can create properties that only live on the Python side or only on the JavaScript side. But in the majority of cases, you will want properties to live on both ends. So let's use this concept, it barely fits, to create a painter application. So in the remainder of this tutorial, there will be a couple of painter applications that grow increasingly sophisticated. So in this case, we only implement JavaScript logic. And anyone who has worked with the HTML5 canvas will probably recognize some of these calls. So basically what happens, we are having a handler here that is connected to the mouse down event. And when the mouse is pressed down, it will draw a dot at the mouse location there. So it's quite easy. So yeah, we can paint dots. So making this a bit more complicated or sophisticated, is this still large enough to fit it on the screen? So now we're adding properties. So we're using it like this so that we can set the properties in Python and use them in JavaScript, or the other way around if you want. But in this case, it's probably setting in Python. We're giving them a default value. So we're making a property for the color and a property for the radius. And then the only thing that we're changing here is that we're using the color and the radius like that. So now we can still paint some dots, but now we can say, well, maybe we want a different color, and then that color is used. Maybe a different size, a bit big. Okay, so this is hardly an ideal way to, if you want to like make a painting, I don't know, to make a more sophisticated painting app, then this is hardly ideal. So you want buttons or some other widgets to select the color. So let's do that. So in this case, we're going to create a widget that's like a wrapper around what we just made. So, so in this case, we create a widget that inherits from widgets. The other one, by the way, inherited from canvas, which is essentially a HTML5 canvas element. Now we're inheriting from widgets. And in here, we define the structure of this widget. So this widget consists of a virtual box, so a virtual container, inside there is a horizontal container, and that container contains a few buttons. And the remainder of the space is occupied by the painter widget that we just defined above. I'll get back to this handler in a second. First show you what happens. So you can see that it works. So we have 3 buttons. The painter widget is here, and we can click them to change the color. So there's quite a lot of magic going on in this event handler. So until now, the string that is used here was quite simple, but you can see that we can actually use a path to an event to connect to an event. So in this case, we're actually connecting to the mouse click event to all of the children of the button box. And the button box is this container that contains the buttons. So essentially, when any of the buttons is pressed, this handler is going to be called. And then we're in the handler itself, we're checking, well, what is the object that was pressed, and then we take the text, and that is what we update to set the color. So this is really all there is to it. And the great thing about this is that the event system is aware that children is a property. So it is aware that when that property changes, we might need to make new connections or destroy old connections. So this event is completely dynamic. So if we create a new widget, a new button, that we're going to add to the button box. So we're saying the parent is the button box. That immediately works without having to do anything else. So automatically, all the events are set up. Similarly, if we would remove a button, that will kill the connections, or remove the connections. And this is a very powerful concept. This allows you to, in a very easy way, connect to different parts of your applications without getting spaghetti code, essentially. Okay, so we're continuing with our painting application, and now we're turning it more and more into a web application. So let's say that we have a function here, getColor, which in this case gives you a new color every second from a simple palette. But let's assume that this is a very special function that, I don't know, that needs to run on the server for some reason. And we modify this painting application. So instead of listening for the mouse down event in JavaScript, we're now listening to the mouse down event in Python, because the handler is defined here. And we're going to, in that handler, we're going to call getColor, and we're going to use that color to emit a new event. So we get an event, and then we create a new event to which we attach data. So we attach the color, we attach a radius, and then in the JavaScript, instead of listening to mouse down, we are listening to the paint event that is emitted over here from Python. And we're going to use the radius and the color to paint. So you can see how the color changes each second. So the mouse event is going to be sent to Python. Python is going to react, sending a new event. JavaScript is reacting to the event to draw the dot. That's basically what happens here. So taking this a bit further, so while I'll explain the next example, all of you who have a laptop in front of them can please go to flexx1.zoof.io and then click on Colab Painting. So there's a standard example in the documentation of Flexx, which is essentially the same painting application that we just showed, except it has a relay object which is global. And all the events are going to pass through this relay, which means that any of the connected users, if any of the connected users presses his mouse down in the canvas, all other users will get a dot on their screen. So you can collaboratively draw a painting like this. So this is you making a painting. So, gosh, this is a bit messy. So maybe, I was thinking maybe you could try, someone is drawing text. I'm not seeing any obscene objects yet, which is good. Before that happens, maybe we can draw the Python logo. I don't know. Okay, so while you try and do that, I'll move on to a next demo. So this demo no, is this? In this demo, we're going to hijack the Python or the Jupyter notebook. So the Jupyter notebook is great. Personally, I don't use it a lot because I prefer like an IDE approach where I have like stuff on the side and plots not inline but somewhere else. So we're going to hijack the notebook and make that work. And to do that, we are going to create a dock panel, which is a very IDE-like widget. And instead of showing it inline, we are attaching it directly to the HTML document. We are attaching it to the body element. And we're going to populate that with 2 widgets just to have something in there. Oh, I think I have 3 widgets now. So we can actually see that it exists here below because it's now below the notebook. And then we have a widget, which is very simple, actually. It was surprisingly simple to make this, which has a JS implementation. Basically, when the widget initializes on the JavaScript side, we're going to take these HTML elements, these HTML document elements that represent the notebook and make them children of the widget, right? And then that widget, so like that wrapper widget, is going to be put into the dock widget. So now we have the notebook. Well, let me put. I executed that cell a bit too often. So now we have the notebook, and we can like move it around and have a more like IDE approach. Right. I should say that all these widgets, especially like the layout or all the layout, is based on a project called Phosphor.js, which you might have heard of. It's also the basis of the Jupyter Lab project that is going to be presented this week as well. So Flexx uses that for all the layout underwater. Well, similarly, we can add a bokeh plot. Oh, it's a bit small. So this is a very simple example of a bokeh plot where you create a figure, we create a circle with some data that we randomly generated. And normally in bokeh, you would at the end say, show the plot, and then it will appear in the cell below. But in this case, we are wrapping the plot in a special Flexx widget. So that Flexx has a bokeh widget, which wraps a bokeh plot. Oh. And then we can attach that to the dock as well. And interact with it. Okay. Let's see what you... Cool. You're collaboratively drawing a cat or a dog. I'm not sure. Finding my thing again. So if you want to play with this, if you get excited about this, it's very easy to install. You can use either Conda or pip to install it. It's pure Python. It only relies on Tornado. The code is on GitHub, and there are docs which have quite a lot of examples that you can try and use and adapt. And, well, to summarize, I think the most important message of this talk is that Flexx is a tool that allows you to write apps only completely in pure Python, and you can deploy them almost anywhere. Thank you. Any questions?
A quick question. I noticed you had some inline styling, and I think you were about to show something, or I thought I saw something regarding CSS. Can you pull CSS into?
Yeah, you actually... let's get the notebook. Like where I showed this, you can like do this, and then have the CSS, and that's going to be included, and you can use it to style your widgets. Yeah. Any other questions?
How does Flexx compare to the alternatives?
Right, that's a good question. How does Flexx relate to the alternatives? So I went a bit quick around this. So I think the most Python in the browser projects can be more or less divided into maybe 3 categories. Like one are pre-compilers or transpilers, which are basically come down to taking Python code or Pythonish code and transpile it to JavaScript. So that's like writing JavaScript except using a Python syntax. And that's like PyScript is the Flexx component of doing that. So the transpiler of Flexx falls in this category. And then there's projects that like have a proper interpreter in Python that you can like execute Python code there, like Sculpt, Brighton, and PyPy.js. And then there's like a third category, which I didn't list here, which are more like frameworks like Pyjamas, which allow you to create like web apps in Python. And well, the whole of Flexx falls in that category together with Pyjamas. Yeah. Other questions?
What are the next steps for it?
The next step for Flexx, well, mobile support would be really awesome because then it would be truly cross-platform. More widgets, better testing. The testing is pretty good, except like to test the widgets, you would have to like test visual output, and doing that is not really trivial. So more work on that. Yeah. Sorry? How do you make it play well with existing frameworks? So yeah, it works. There is a way in which you can include assets. So if you have access to, like for instance, the bokeh widget works by when you instantiate a bokeh widget, there will be like an asset that is created, and it will be loaded onto the client side, so that bokeh is loaded there, and then that you can show the plot there. Because as you saw, we didn't like do the bokeh magic to make the notebook work with bokeh, because that's handled by Flexx. And similarly, there's an example using can't remember the name. There's like a calendar widget with, I lost the name of the framework, but there's an example of including other frameworks as well.
Like JavaScript frameworks too.
Yeah, JavaScript framework. So you can basically specify the client should now load this JavaScript library or this CSS to do that. Yeah.
Would it be possible to like select points in a scatter plot and then have the Python know what you selected?
The question was whether it's possible to make a selection in the scatter plot and let Python know what happened. Well, that's a very specific issue of the visualization library. So if you're using bokeh, yes, that's possible, but then you would have to probably do the bokeh logic. If you would like create a scatter plot yourself using the canvas or whatever, then that's pretty easy to do. Yeah. So it depends a lot on how you make the scatter plot, I guess.
Are there examples for Flask or Django?
Yeah, there's one for Flexx and Django. No, it runs on Tornado, and now, I try to make it not too tightly coupled, so all the logic related to Tornado is constrained to a single module, and it should definitely be possible to make it work on Flask, but it would require some work to do that, but it's not impossible. Yeah. The basic thing is you need a WebSocket. That's the most important part.
Why do you need a website?
So the connection between Python and JavaScript is made using a WebSocket so that you can very easily exchange messages. Like if you would use Ajax, for instance, it would like not be as efficient because of setting up the connection and all that.